Hey again, everybody. Today we're going to be talking about domain-driven design. So this will be a slide-heavy presentation. I'll try to get through it as painlessly as possible, and then we're going to do one more video after this that'll be slide-heavy about microservices, and then we're going to start jumping into writing code. So domain-driven design. It's a large topic, so we're obviously what I'm trying to do is really condense it down into a very shortened version. I would highly recommend if you don't own the book that you go out and you get the original Domain Driven Design written by Eric Evans and go through it yourself to really get into the nitty gritty details. But what are the components of domain driven design at a high level? Often shortened to DDD, by the way. So we're going to talk about in this presentation bounded contexts, ubiquitous language, entities, value objects, aggregate roots, domain events, integration events, repositories, and services. And it's my supposition that if we go through these, you're going to come out the other side with a reasonable understanding of what makes up domain-driven design, and then we're actually going to see it being implemented in practice. And I think that's where the rubber will hit the road, and it'll start to come together if it doesn't by the end of this presentation. So let's kick it off by talking about a bounded context. What is it? It's basically a subdomain within a larger business domain. Super clear, right? Well, the idea in domain-driven design is you should be focusing on the business perspective of what needs to be built. And there's in larger applications, larger organizations, there's a lot of functionality that could end up being in an application. And trying to fit all that functionality and how it all interplays with each other in your brain can be overwhelming. And I'm sure you've might have been part of organizations where somebody pulls out the domain model with all sort of the classes, the major business object classes that make up an application, put it on a whiteboard or printed it out and put it on the wall, and it's ginormous and it just looks overwhelming. The whole idea in bounded contexts is to say, well, no, let's break the bigger problem down into smaller ones. We're we're going to break down the domain of all these objects that and classes and functionality that make up a particular domain within the business into smaller subdomains. And what that usually results in is you end up with subdomains that are often aligned, not always, with the different departments that might make up the organization. So you could end up with an accounting subdomain and a customer service subdomain and other subdomains as well. The idea, though, is there's a couple of important things about the bounded context, which is within a bounded context, so within a particular subdomain, you want to define and use terminology that the business uses. So you want to agree upon terminology that you're going to use, and you may end up with similar concepts and similar objects or business objects in multiple domains because in a lot of organizations there might be an object called a customer, and what does a customer mean to the accounting department versus what does a customer need to customer service department are usually two very different things. So within each bounded context you're going to be able to have a customer object. They're going to share the same primary key, but they might have different attributes. So you could have the same object in more than one subdomain, but the attributes and the functionality that it makes it up could be quite different because it's the class within a given bounded context is meant to represent that object in that context. So a bounded context obviously should contain a group of related concepts in language, right? So a bounded context, you want high cohesiveness between the objects that make it up. And then I figured I would throw in here our shopping example that we're going to be building. I've broken it down into bounded contexts that represent our product catalog, inventory, orders, customers, which I've actually renamed to accounts, sorry, payments, shipping, and I'm missing one there called recommendations. Point being, you can see there's a high degree of parallel, in fact, one to one, between what I'm calling a bounded context and what we're going to build out as a microservice. So there's a lot of parallels between domain-driven design and how to think about, the business domain problems that you're solving in bounded context and in domain-driven design that very much align with the principles of microservice building. What are the boundaries of the microservice? They tend to be the same boundaries as the bounded contexts. So domain-driven design does not mean you have to do microservices, and microservices does not mean you have to do domain-driven design, but the two marry together very, very nicely. Um, so as I talked about, the same class may appear in multiple bounded contexts, but with different attributes and methods. And bounded context should be able to evolve independently. And as I said, they go hand in hand with the microservice boundaries in a lot of cases. So, next topic, ubiquitous language. Despite being just a fun, fancy word to say, it's actually a very critical thing that I think is often missing from a lot of development, um, from the development process of a lot of applications. It's a documented language that is tied to a specific bounded context. So it's almost like a dictionary, where you are going to have terms that you define and you agree upon with the business, and it's tied to the bounded context. So if I'm meeting with the accounting department and there's a bunch of terms that we want to call things by or reference things by, different objects in the bounded context, we're going to agree on those words, those names, and their meaning. And that's super important because if we can get an agreed upon language and we keep it in sync, that if we learn there's a better term for something, that we also update the code, and all other relevant documents in accordance with that change, we end up with the second bullet point, which allows a consistent language across conversations about the product. So if we're talking with the business folks, we're not interchangeably using different words for the same thing. We're not coming away as developers thinking we understand a concept when in fact maybe we don't. If the domain models that we build out, if the user stories, the user interface, the source code, and all the documentation all use the same words, you can easily navigate between, say, a user story and source code, or domain models and source code, or any of the above, right? So it makes sure that we have a unified way of referring to things in the code, in our conversations with the business, and the requirements, and the documentation, which is huge. And a lot of people will create a ubiquitous language at the beginning and then start introducing new terms, which is totally fine, or changing the name of a given term, and sometimes update the ubiquitous language, but don't update the code. I highly recommend not following that practice. I very much am a fan of keeping it all in sync. That if you're going to take the time to change the ubiquitous language in a term that you've defined, make sure you update all of the other corresponding documents and code that refer to it. Um, and then the last bullet point is that, as conversations are happening, like if somebody starts introducing a new term that is not in the ubiquitous language, it's a big signal to say, ooh, wait, is that actually something new that we don't know about, that we might have to incorporate into our thinking or our design or our application? Or is it just they've pulled a new term for something we've already defined out of a hat? And in those cases, it's just important to investigate whenever you hear a term that's not in the ubiquitous language. And if it turns out that it's just another way of referring to something, then try to encourage everybody to say, ooh, okay, thank you. Good to know that there's an alias for it, but let's use the terms we've agreed on. Ubiquitous language leads to no ambiguity in the terminology, no situations where multiple terms are used interchangeably, and developers can read user stories, UI UX designs, and code and see consistent terms. And that's a big, big thing right there. If changes are made to the terms, as I said, I highly recommend that you update the ubiquitous language, user stories, UI UX designs, and code so that everything remains in sync and you don't have a drift. Next topic in domain-driven design. Now we're going to actually start talking about like what are the actual things we're going to be creating class-wise within the code. We want to start with the concept of something called entities in domain-driven design. So an entity is a business object that business objects that have a unique identifier that remains static throughout their lifetime. And entities are identified by their ID, not the values of their attributes. And a person object is typically implemented as an entity. And I've shown a little table there, a sample table of what we might be tracking for people. And we can see there's two people that are both named Jane Doe. And let's say that we had an object in memory, a person object, and we didn't have the date of birth field on it. We just had two people in memory called first name, last name, Jane Doe. How do we know if they're actually the same person or not? Well, we can't just compare the first name and the last name because there are more than one person on the planet that share names. And it's the ID that we use, a traditional primary key, generated by the system, to differentiate whether or not they're actually the same, right? So I think this is what most of us are used to. We would have two objects. There's a unique primary key that we use to identify their uniqueness. If the primary keys match, then it is the same object or the same entity. If they don't match, then they are not the same. And I think that's aligns with how the majority of people think when they're thinking about object-oriented programming. So entities shouldn't be too earth-shattering, I don't think. Then there's a concept called value objects. Value objects are business objects where the attribute values define their uniqueness. And the value objects are immutable, which means we cannot change its properties. We must create a new one. And a good example of that is typically addresses, phone numbers, and things like that. So we were just looking at a persons table where we had two people, and their uniqueness was defined by their ID. When it comes to addresses, if we had addresses in a table, and we had street, city, state, and zip, the way we would determine are two addresses the same is we would actually compare the street values, city values, state value, and zip value to each other. And if all four attributes are equal between the two objects we have in memory, then we do have the same object and the value objects are equal. So again, phone numbers is another great example of this. And I do think when we finally start implementing, and you see in our example application, as we start to implement entities and value objects, I think it'll become even more concrete. The distinguishments between them. But the first two bullet points are really important. So business objects where the attribute values define the uniqueness, and the value objects are immutable. And we'll see what that ultimately means from a coding perspective of if we wanted to update, say, the state on an address, means we can't just take the object and update its property, setting the state to the right value. We want to create a whole new state that a whole new address that replaces the previous address, and we'll see examples of that. Next one is aggregate roots. And again, I think examples will be abundant when we're writing the code, and we'll bring a lot of clarity to this concept. But aggregate roots. So you could think of this as sort of the hierarchy tree of a document or an object that we might have in memory. If we had a person object, and off of that person object we had a collection of addresses and phone numbers by which the person could be reached, we would often think of the person as the root of that relationship, and the addresses are really a child collection, as are the phone numbers. And in that case, what we would be referring to the person as is something called an aggregate root. The aggregate root, so if you have a bunch of entities and value objects that together sort of make a hierarchy structure, the rootmost entity on that will be your aggregate root. So in the example I gave there, the person object would be the aggregate root, and you could potentially have multiple collections or individual properties that point at entities and value objects as a whole, but there's only going to be one root level entity, and that will be the aggregate root. And so why is it important to distinguish that from other entities? Because there's a bunch of rules about aggregate roots. So I would personally recommend printing this out and having it handy if you're not familiar with domain-driven design. As we go through the other videos, have this handy because you're going to want to be reminded of these rules as we move forward. So Most important thing, AR, aggregate root rule number one, aggregate roots can be saved and retrieved to and from the storage, but only aggregate roots can do that. So when we are transactionally writing something to the database or retrieving something from the database, we are writing and retrieving aggregate roots. That doesn't mean we don't save the things under the aggregate root. It just means that what we pass to the database to say save this thing is the aggregate root, which could be it plus all of its children, and it's responsible for persisting its children and so forth. So when we talk about the repository pattern, the thing that allows us to interact with the persistence layer, it's the repositories that really handle the saving, the updating, the deleting, but what we're passing in and out of the repository are aggregate roots only. So when retrieving an aggregate root from storage, all of its child entities and value objects are retrieved at the same time, no lazy loading. So we're not going to bring back a person object and then not bring back their addresses and phone numbers in the example I gave. And then the first time somebody tries to access the addresses collection, then we lazy load it. We're not going to be doing that. So aggregate roots as a whole move in and out of storage. So as a whole, meaning all of its children go along for the ride with it. And for that reason, rule number three is aggregate roots should be small. Like we don't want huge object structures and trees of objects because aggregate roots go in and out of storage as a whole. We don't want them to be huge so that we're not taking up a ton of processing time moving things in and out of storage. Rule number four, entities and aggregate roots can reference another aggregate root by its ID only. So let's talk about our shopping world example. So uh, if we were talking about the shopping cart that represents a particular cart that somebody has started, we want to be able to reference and know who owns that cart, so a particular customer. We also want to know a collection of products that they've added to the cart. In those cases, we're going to see that we're going to have a shopping cart class, and it can reference, okay, who owns it. But we're not going to, the only thing that we're actually storing and we're making available in the properties of the object, because we're going to be referencing another aggregate root, a person or an account that owns the cart, way we do that is with the ID only. So there's going to be a GUID property, the primary key, a GUID property on the shopping cart that says owned by or something along those lines, and it will be the ID of who owns it. We're not going to be bringing in the entire relationship. We're not going to bring in the entire person object and represent that on the aggregate root. We're just going to have the ID to the person, and we'll see that in action. Aggregate roots, rule number five, are responsible for making sure all of its properties and child entities and value objects are in a valid state. So if we're about to send an aggregate root off to the database to be saved, and we want to make sure that it's in a valid state so that we don't store an invalid object in the database, the aggregate root is the one responsible for, I should be able to ask the aggregate root, are you valid? And he should know is not only his properties valid, but all of the child entities and so forth that make him up. So he is responsible for the validity of the entire tree structure. And so you can see the aggregate root plays a very primary role in terms of it is the boundary around which we say this thing will transactionally move in and out of the database. It's responsible for the boundary of validation, has a lot of key responsibilities. Number six, aggregate roots are the entry point for all queries and commands posed to one or more of its child entities or value objects. What that means is if we're interested in querying the aggregate root for, I don't know, let's say that we had a collection in the person object, again, of addresses, and one of the addresses is the primary address and the others are, secondary work, etc. That the query that we would want to run, we want to issue that to the aggregate root saying, get me this person's primary address, right? So we'll see examples of that are entry point to retrieving data or some information back from the aggregate root, even if it's related to one of its child entities. The entry point should be through the aggregate root, through methods on the aggregate root. And then rule number seven, aggregate roots act as a transactional unit, meaning an aggregate root and all of its child entities and value objects are successfully saved together or failed together. So you can think about that as a typical database transaction, right? So if there's multiple things going on within the aggregate root, multiple things changing, and then we ship it all off to the database to be saved. If we successfully save part of, say, the aggregate root, but one of its children fails to be saved, then the whole thing fails. So you can think of that as a typical sort of transactional system. So again, the aggregate roots acts as a transactional boundary for validation, for saving, for referencing information, for getting information. A lot of responsibilities there. All right. Next topic is domain events. What are domain events? Basically, when an aggregate root or entity wants to inform other aggregate roots in the same bounded context about changes that have occurred, they issue domain events. So there's some stuff to unravel there. So again, let's use examples. Let's say that in the order management system, when a new order gets created, we also need to create a shipping label. And there's some other class that's responsible, set of classes that's responsible for all of that. So when our domain object that represents an order being created is actually created, what we want it to do is issue a domain event that says, hey, order got created, here's the details about it, and basically pass that out as a domain event. The aggregate root or entity that is issuing the domain event does not know or care if there's anybody listening on the other end. It's just a way of announcing to everyone else within the bounded context that something of interest has occurred. So the order class is going to have the ability to say, hey, new order just got created, and here's a domain event with some attributes about the order that got created. And don't know if anybody's listening, don't know if anybody cares, but those that are listening and will care will respond to it. So the aggregate roots responsibility is to basically publish a domain event and let everyone else within the bounded context who cares about that domain event subscribe to and react to it. So the second bullet point, as I was mentioning, the issuer of the domain event has no idea if anyone is interested in it and is not going to wait for a response. So when it issues a domain event, it's not sitting there waiting for any sort of response because it has no idea, and we don't want to couple them to anybody on the other end. So it's not going to wait for a response. It's just going to issue the domain event and move on. And the domain event reduces coupling now because it means that the two classes that may have an interest, one class may have an interest when another class's state has changed. As I was saying with the order, the shipping label service or classes may be interested when a new order gets created. But the order class itself should not know, hey, that there's this thing called the shipping label and it cares. Like it should not have to know that class exists and that it should be notified, when a new order is created. So it really leads to decoupling because it means that the order class is allowed to concentrate on what it is responsible for, which is basically creating new orders and tracking the state of the order and letting other people know that it happened, but not caring if anybody on the other end is listening. Also, what it means is the shipping label service has no idea who issued the event. It just knows that, hey, if an order created event comes along, I'm interested in it because I'm going to go off and create a shipping label for it. Doesn't have to know who issued the event, how it got issued, when it got issued. It just knows to react to it. Domain events are past tense, meaning that you're reporting on an event that has already occurred. So we'll see that in our naming convention. So in our example, the order gets created. We're going to fire off a domain event called order created, past tense, because it's already happened. And we want to use past tense in our naming. And then domain events are issued and handled within the request response transaction. What does that mean? So if a front end client or a client of some kind has called, made a request to our APIs, and maybe it was to create a new order, what we're going to be doing is the new order class will issue its domain event. But before we wrap up and this transaction at the database level and fire a response back to the caller who called the API. We want to issue and take care of all of our domain events. Let them influence what other objects state may need to change, and then finish the transaction at the database level and issue a response. So what you might have noticed there, though, is we said we're going to wait. So the issuer of the domain event is not going to wait for a response, but we are going to wait within our database transaction to make sure that any domain events that were issued have been completed, and then we can send a response back. So there's a really important part to that, which is, in the very first bullet point, I mentioned that they have to be in the same bounded context. The reason for that is same bounded context means same microservice, and we don't want a situation where we have issued an event that some other microservice has to respond to or handle because we don't even know if it will or when it will, and therefore we can't hold up the response to the client based on that. So again, a domain event is going to happen in memory. We're not going to go out to an event bus like say like a RabbitMQ event bus that lives outside the microservice. Domain events live within the same process, within the same memory. So the domain event will get issued. You can think of there just being an in-memory event bus. And those domain events will be handled prior to sending the response back to the client. So it'll all be part of the same transactional unit of work at the database level. And it will succeed or fail together. The main transaction plus any domain event transactional items that need to be taken care of are all going to be part of the same database transaction. So with that in mind, there's another concept called an integration event. I had mentioned that we need to not call out to some other microservice with our domain events. Domain events are not intended to alert anybody outside of the bounded context or outside the microservice of something that occurred, but there are times where we need to and want to do that. So how do we do that? That's with an integration event. So when a bounded context wants to inform other bounded contexts about changes that have occurred, they issue an integration event. So in our order world, when a new order has been created, there will be other microservices that would probably care. For instance, the inventory microservice is probably going to want to now deduct from the known available inventory of a given product, now that an order has been placed, whatever products are in that order, we need to reduce the inventory levels at that point. So, how do we let that other microservice know and react to that? Well, we do the same thing, a very similar thing. We issue an integration event, and again, it will be past tense. So you're going to see a lot of repeated lines here that are verbatim what we just saw for domain events. They're going to be past tense, and we're going to issue it. This time, though, when we issue the integration event, we're not going to be doing that in memory. We're actually going to go out of the microservice onto some sort of event bus, persistent event bus, like a RabbitMQ or Azure Service Bus, things like that, or sorry, Azure Event Bus. And this is how we communicate between microservices. So there was a picture that we're going to see in the microservices world where all the microservices are communicating asynchronously with an event bus. So when the order gets created, the order class is going to issue an integration event to let other microservices know that an order has been created and choose whether or not they want to react to it. So again, we end up with a highly decoupled situation where the order doesn't know if any other microservice cares that an order has been placed. And the ones that eventually receive the event that an order has been created have no idea what microservice was responsible for issuing that event or how and when it came about. It just knows, hey, I'm interested in that, and I'm going to respond accordingly when I receive that event. So what differs are really the last three bullet points. A typical implementation uses a publish subscribe approach using like an external event bus. And then since integration events cross bounded contexts, that means they likely cross microservices and therefore typically implemented using a messaging service like RabbitMQ. So we're going to see this again. Domain events and integration events are 100% the same concept. Domain events stay within a bounded context. Integration events cross bounded contexts. That's the main difference. So then we have repositories. Briefly mentioned that before. So when we're talking about aggregate routes and the fact that they can move in and out of the persistence layer, we do that through repositories. And so repositories are classes responsible for saving and retrieving aggregate routes. Notice that we don't say entities, we don't say value objects. It's only aggregate routes. And then finally, we have services, which are, you might have services classes that you've built for things like sending email or, sending push notifications and things like that. So those are actually really important services within an application, obviously. But when we talk about services here in domain-driven design, that's not really what we're talking about. We're more so talking about business services, right? So those are more like implementation services of, hey, we need to send some sort of notification, and we need a particular way in which we do that over email and things like that. Services in the domain-driven design world, you're still going to have the services I just mentioned, like sending emails and all that, but the domain-driven design services are meant to implement business logic. So when do we need them? Well, it's whenever there are classes that handle business logic that might span multiple aggregate routes or doesn't logically fit within one of the existing aggregate routes, then it oftentimes means, hey, let's put that into a service that can handle that. So one other really important thing to mention here in domain-driven design is we do not end up with there's a term for something called anemic classes. Anemic classes is when you end up with classes where you have mostly just data. That the class has a bunch of properties, and you can get and set those properties. Doesn't really have a lot of methods. The constructor is kind of uninteresting. May not have any methods, and you end up with basically just a class that hosts some data, and the external code must figure out how to interact with that data or how to update the data of those properties in a way that does not invalidate state. And we do not end up with, and we do not want anemic classes in domain-driven design. We want to bring the richness and the knowledge of the understanding of the business rules and what can be changed and how to change it into the classes and the business objects themselves. So it's another really important point of domain-driven design, and we're going to see that, and I'm going to talk about that as soon as we start writing some code. I'll touch on that again. So hopefully this wasn't too bad, but this was the first of two slide-based presentation videos. This one was about domain-driven design. Our next one is going to be about microservices, and then we're going to start actually getting into the code.
Time for a shameless plug for my personal LLC, Keystone Code. I've been doing software development for 20 plus years now, and I've been lucky enough that I've played a lot of the different roles that go into software development, from back-end developer, front-end developer, full-stack developer, team lead, head of engineering, chief technology officer, business analyst, and architect. So if your agency or company has any needs across those different areas, whether it be a need from just understanding what those roles are, or have a need to fill one of those roles, either from a training perspective, a mentor perspective, or an actual hands-on perspective, feel free to reach out. So I can be reached at my email address, dmichael@keystonecode.com, or on the website at keystonecode.com. Thanks.